Hi, welcome to my video. Here's my little logo, What's Cooking Research Project. And this video is Eclipses, Ratios, Realities, and Bad Science. A video by me, Robert Scott. First, we have this information from the U.S. Naval Observatory website saying that the umbra, the shadow the moon will cast during the coming eclipse, is going to be 73 miles wide. In all my research, that's as wide as it will ever get. Let's look at what's supposed to create this 73-mile wide shadow. The moon at 2,159 miles in diameter and the Earth at 7,917 miles in diameter. So they say the Earth is 3.6669 times the size of the moon. What wonderful numbers. The darkest part of the moon's shadow during eclipse is called the umbra. On October 21st, it's going to be only 73 miles wide. The shape will vary like an egg or more like a circle, but the width, total width of that area of totality is only 73 miles at any given time. Okay, so the distance between the Earth and Moon varies daily, going from far distance back to close distance every 28 days. Only when it's close do we see a full eclipse. October 21st, the distance will be 233,429 miles. The theory says that if the moon is too far away, it'll be an annular eclipse and not fully, not totally dark. Here's the diagrams that NASA and mainstream science shows us, and it shows like the light from the sun is converging. I don't know. And it says also that the umbra gets smaller with distance. Well, that might have to be because the umbra's starting out at 2159 and reducing down to 73. But let me show you something, folks. That makes no sense. It doesn't happen. Okay? Let me show you what actually happens with shadows. In order to understand what actually happens, you have to understand what's not happening. And this picture is not the way the solar system, the way the Earth, the moon, and the sun are related. It's just not. Okay? So everything I've explained is what the standard model is, and none of it explains an eclipse. But I'm going to show you what really does happen. For this demonstration, I use as a light source this small LED headlamp with a reflector on the back as the sun. And for the moon, I use this 33 centimeter ball supported by a thin piece of wire. And then the target where the Earth would be is this white piece of paper with a 33 centimeter circle on it attached to a white background. The lamp is put on top of a box which I can move back and forth down the hallway and aim it at the target. So let's see what happens. Here we have our target with a light source on it, and there's our moon, the shadow, and there's the real thing. I'm going to bring it right up against the target. That little circle is the exact same size as the ball, and so as I bring it up as close, if I can get it there, it's hard to spin it from the little wire. There, you see it's the same size. It covers the exact same size. Now I start pulling it away, and as the distance increases, the further the distance of the shadow is cast, the larger the shadow becomes. And it really has a lot to do, I believe, with the ratio between the distance, the total distance for the light source to the target, and how much the distance, the ratio between that light source and the moon. So now I'm at least 50% halfway between what would be the Earth and the sun with the moon now. And you start to see this penumbra. You start to see this light shadow on the outside and the dark shadow on the inside. Now this only happens with a focused light. In other words, I have that reflector on the back. If I have a single point of light, like a single LED, there will be no outside fuzzy edge. It'll be just one opaque disk, no matter what you do with it. And so now I'm about 90% the distance to the sun. So if it was 10 feet away, it would be like 1 foot away from the sun. The moon would be just 1 foot away from the sun. So very close. Creates this type of image. Okay, but you see that umbra, that central opaque shadow, is much, much larger than the object that's creating it. Okay? It would be the equivalent of the whole size of the Earth there. If it was the moon at 2,000 miles across, and it was 90% the distance to the sun, it would produce that whole, it would cover the entire Earth. But it doesn't. It only goes 73 miles wide. That's what I'm telling you. The idea of the moon at a great distance of 233,000 miles away, creating a shadow that's only 73 miles across, is physically impossible. Absolutely, totally impossible. Even with the focused light, which this is. This beautiful artist rendition of the formation of a umbra and penumbra shadow from the moon would be absolutely beautiful if it weren't in total contradiction of the known laws of physics and all observations we've made of shadows and light. You could say, well, it's a focused light. Well, it has to be a focused light to create an umbra and penumbra, but the umbra is never smaller than the object creating it. Okay? So, in that way, this is an ugly thing. It's wrong. It's false. It's fake. It's a lie. It's a visual lie. This is a depiction of the actual distances involved, how tiny the moon is compared to the Earth if it's at that distance at 225,000 miles. That's what they would look like. That's what they'd look like. The sun itself, that is stretching across your screen at about a foot or so. The sun would then be, 100 feet away. Way, way far away. And yet, even this, it doesn't work. The shadow can't be smaller. Okay, here we are back to our beautiful lie. Even though they could make up whatever they want there, they still didn't get it anywhere near correct. The distance between the Earth and the moon, if they were that size and that shape, is not anywhere near correct. It would be, so far off the screen you can't even see it, as I depicted just before. The penumbra, that is not 73 miles on the globe, on the Earth there. It's at least 250 probably. It's huge. And the penumbra is not as big as they predict it will be. And their predictions are correct. They're based upon observed data. But this explanation is in 100% contradiction to observed data. That's my point. The explanation of how it happens does not comport with any of the observable realities of light, physics, shadow, etc. This is a picture of the LED light, little pen light, little key light, a single LED for my demonstration of a single point light source and how they create shadows. Okay, this is another demonstration of a single point light. It's an LED just from a single white LED, no back reflector, and the ball is the exact same size as the center circle there. See the center circle? And as we pull it away, it gets larger. No penumbra forms. No penumbra forms. There's a slight little area around there, but at this point, if it were a focused light, it would have a penumbra 4, 5, 6 times the size of the center. But regardless, the shadow, as distance increases, always becomes larger. Period. You can do it until 1,000 years pass away with 10,000 people a day, and it'll never change. The shadow never gets smaller with distance. Case closed. So now I've told you what doesn't work as far as an explanation, and yet we have seen this type of picture before. There is something that blocks out the sun, but it's important to note that when it blocks out the sun, the center part, there's still plenty of light going around the Earth. Now we see what's called the corona here, and what is that? Well, the sun ionizes air in the atmosphere. And I'm going to prove that to you in just a second. Okay, let's take a look at this. this is an actual photograph taken at a high altitude from the balloon. Notice that when we look up at the sky day to day, and if we see the sun, it is surrounded by a field of light blue, a field that gives off its own light too. If the sun were just a single point and creating light from just a single point, it would be in a black background like we see here. But notice in this picture, above the vast majority of the atmosphere, the air is very, very thin up here. Airplanes cannot fly. There's no jets and actually rockets that can't even fly. Here's about 120,000 feet. But you notice two things. Of course, the Earth is flat there. Second thing is the air below it is glowing. The sun's electromagnetic radiation ionizes the atmosphere, the air, and it glows. That's why we see a bright blue, light blue sky that is giving off light in addition to the sun. And look right directly below the sun, that's a hot spot. Hot spots like that are formed by focused lights. And so somehow between the sun and the atmosphere, the light is focused. It's not 93 million miles away. It's actually very close. This is another picture, and a very accurate picture. It's an actual photograph taken from about 120,000 feet or so, maybe 128. And you see there the sun is very close to the surface of the Earth. And you see the light is directly below the sun is a hot spot. It's not been retouched. This is what it actually looks like. And so now imagine that the moon or some other black body in connection with the moon is between where you see the sun is and the surface of the Earth right below it. And the sun moves faster than the moon there. If they're really close, then that shadow will sweep quickly from west to east, even though the sun and moon are moving east to west. It makes sense with that model. Now let's talk about levers. Here's an example of a long bar with a pivot there on the right. If you push down 1 inch at point B, it'll make 10 inches of movement at point A. What difference does that make? Let's take a look. So, if instead of a lever, we have a position of the sun and the moon and the resulting shadow in the same configuration, a small movement difference between the sun and the moon creates a large difference in the movement of the shadow on the surface of the Earth. Here I've created 3 different repeating diagrams showing how the sun can be moving east to west, and yet the shadow moves west to east because it's passing the moon. Only a slight amount of movement is necessary to cause this action between the two because they're so close together, and yet the distance is quite a ways away from the Earth. So, and this is not perfect. I didn't get the shadow down as small as it actually is on the would be on the map, 73 miles, but the principle is there. The distance I'm showing the sun from the surface of the Earth might be far in excess of what it actually is. All these estimates and times and speed of the shadow have been calculated by this man, Frank Espinac. He's probably the best in the world at what he does, and that is estimating where the eclipse will show and the speed of its shadow and the width of its shadow. Now, how did he figure that out? Frank Espinac applied a method created in 1824 by a man named Frederick Wilhelm Bessel. Are you ready for this? His technique transformed the motion of the sun and moon into the position, motion, and size of the moon's shadow with respect to a plane perpendicular to the moon's shadow. Bessel called it the fundamental plane, and it was a rectangular plane with an XY coordinate system. That's right. He calculated the location and speed of the moon's shadow by mathematically projecting it onto a flat plane. No wonder it works and is still in use today. Thank you for watching the video. Much more to learn about this subject, but that's all for now. Thanks.